code. I'm going to start with an apology. I'm really not feeling very well. I'm very snuffly, my eyes hurt, and my brain is not working at the speed it normally works at, which is probably a good thing for you, because usually I whiz through my slides and finish really early. Today, I've got my notes, I'm on go slow mode, okay? Right then, who am I? My name's Emma. I'm going to be really, really honest. I am not an infrastructure developer. I have never written a line of production infrastructure code in my life. However, I am a software developer by career. I was previously head of development for a financial services company, and about this time last year, having been to a DevOps conference, the people the likes of Helen inspired me to go and teach the world to DevOps. Okay, so late last year, I co-founded a DevOps consultancy, and really I'm going to talk to you about the things which I've learnt over the last 12 months around infrastructure development as opposed to application development. Okay, so at NewBeGo, we have a series of internal tools that we've built ourselves over the last few years. I came in as the development specialist in September, and within about a week, my co-founder started mothering me. He was saying things to me like, don't forget to put all your code in a source code repository. I was like, yes. Don't forget that all our deployments should be totally hands-off. Yes. Oh, and have you tested that thing before you pushed it into production? Yes. So when he does this to me, when he mothers me, I've been known to utter some immortal words. Trust me, I'm a developer. Okay? So I've learned from working with him and with the team over the last sort of 8 months, 9 months, that there are certain things from my software development history that I have come to take as granted. Things which are happening in the infrastructure development world, but which probably aren't quite as mature in terms of processes, tools, and technologies. And quite often, when we have one of these dev versus ops moments at NewBeGo, I remind myself that we're on a journey. A DevOps journey is not just about dev versus ops in our office. It's around exploring the right tools and technologies. Okay? So, I want to talk to you a little bit about my career, why I'm qualified to share with you some of the application development best practices. It's what I do for a living these days, is I guide others on software best practices. So I've been doing this for about 15 years. I'm a Java developer with a smattering of JavaScript and C# in there, C++ if I absolutely have to. And these days, for fun, I write Alexa skills and I build all my own stuff in AWS. But like I said, I've never written a line of production infrastructure code. Okay. So today we're going to talk a little bit about agile development. And you'll see some of my themes today map quite closely onto the Agile Manifesto. We're going to talk about simplicity in infrastructure development. So the art of doing as little as possible. We're going to talk about how do we build technical excellence and technical design into our infrastructure development. I am going to gush, I think is the right word, around quality in infrastructure development. And then towards the end, I'm going to talk about my favourite topic, and that is really the thing which underpins all successful teams, is having a clear sense of purpose and sense of shared ownership. Okay? So, let's start with simplicity. As a Java developer, it has been drummed into me that reusing code is good, duplicating code, copying code is bad. Okay? It's a habit I can't unlearn, I don't think. The first thing that I do is go and look to see whether somebody else has built something already which does what I need it to do. Okay? So, in the infrastructure world, at NewBeGo, every time we take on a new project for a client, which requires us to go and build Terraform code on behalf of them, that bit's squeaky, the first thing we do is we check online to see if there are any public repositories. So in the Terraform registry, there are modules available. Go have a browse, see whether they suit your purpose. What we tend to find is that for each client project that we work on, there are similarities. There are things approximately that we need out there, but none of them do exactly the right thing. So as a software developer, I have fought for most of my career against this feeling inside me that I know best and that my code is the most beautifully crafted of all code, and that I can do things better. And it's quite a hard habit to get into, to force yourself to go and look elsewhere to see whether somebody else can do it better than you. But we're practicing. When Helen talked earlier about improvement katas, this is one of the katas that we're practicing. So I'm tasked with a new Terraform module that I need to write. First thing I do is go and check elsewhere. Okay? To date, we've found one that we wanted to reuse, but the rest that we've built ourselves. And that's something that we're doing internally, is building our own registry of Terraform modules. So we're small right now, but as we grow, we're already seeing similar patterns for each of our clients. So client here wants to bring up a new AWS organization. It needs N accounts, it needs to integrate with SAML, and it needs the following login configurations. Okay, the next client that came along had exactly the same need. So we already had the Terraform modules built. All it needed was a small amount of customization to wrap them together to suit the second client's need. So we're already building our own library internally of Terraform modules. But the message I'm trying to get across is go make the most of your community around you. In the open source development world, we now have this mass of contributors who can share their code with us. And I think we're only just learning that in infrastructure code. So I've listed out for each of the various different tools we use, the first place to go and look. Okay, they're the obvious ones. They're the official registries in most cases, but they're the first places to go and look. I was a talk just a second ago about Amazon EKS, and there was a recommendation in there for a place you could go and look at for CloudFormation templates. That you don't have to just go and look at the default Amazon CloudFormation templates. They're a good starting point. But there are lots of people now starting to build out this public library of things they've achieved already that they're happy to share with us. Okay? So I'm currently working on a project in a financial services organization where people would shudder if they thought that you were taking things off the internet that other people had built. So we're not always in a position to go and download off the internet other people's work. Perhaps you might even go review some of the things here, go and learn from them, but then decide that they're not doing exactly what you want to do, but at least use them as a starting point. But if you can at all go and reuse something like for like, then I would encourage you to do so. It will save you time, I guarantee it. It will save you time. Somebody else has spent all the hard time researching it and building it and testing it. If you've taken it from one of the official registries, then it will have been verified to do what it says it does. Okay, that gives you more time to go and look at your specialist area. So I'm not a specialist in IAM, I'm just not. If somebody's already written a module which does it for me, then it means that I don't have to go and learn the details about IAM security. I should know them already, but I don't need to delve into the details. I can spend my time focusing on building DevOps tooling. Okay? So that's simplicity. It's around code reuse, and I would encourage everybody to at least start internally reusing code between teams or between individuals. Okay. Quality. You could probably tell from my introduction that this is my bugbear. I've been doing development for 15 years. When I first started, unit testing was the thing which all the new people did. All the grads on the graduate training scheme did unit testing. Everybody else was like, why are you wasting all your time? Okay. 15 years on, I still see development teams who want unit testing. I have no excuses. I do not know why they are not unit testing, but we work together to go and instill unit testing as just a habit that you do. So for most of the application teams that I work with, unit testing, nobody thinks about it. It's just a given. It's a fact now. And yet, with the infrastructure teams that I've met over the last few months, nobody's unit testing. Is anybody in this room unit testing their infrastructure code? 2 people, 3. This is amazing. Even my own team, when I said, hey, I'm writing these slides about unit testing, can you show me some of the examples? They all just looked at me like, whoa. So, unit testing is a big investment of time. And I would say that if you can get over the hurdle, and the hurdle's definitely up here, you will see the benefits to it. So you slow down to speed up. Yeah? I want to slow down, write shed load of unit tests, and then it assures the level of quality when I get to the other end. Now, the client that I'm working with at present, their quality levels are really, really high. And that's because they've got that foundational level of unit tests. And we saw it in one of the slide decks earlier. If you've got that foundation to build on, then you can go and invest more time on the scary, risky stuff. Okay, so I'm going to talk a little bit about how we unit test Terraform. Okay, so not my current team, who should watch the slides, right? Unit testing Terraform. Terraform gives us, out of the box, a very basic level of testing. If you use Terraform Plan in a sandbox environment and go and understand the changes it's about to make, you're testing, okay? It's a basic level of testing. But testing as part of your CI pipeline, you layer on different types of testing. So the first one that you can put in is linting, and we'll talk a little bit more about that in a minute. Then what I would recommend is that you go and spin up a sandbox or an ephemeral environment of some sort and go and actually apply your Terraform configuration. After you've applied it, then you can start running tests. And there are a series of frameworks that you can use for testing Terraform. Largely, they will come down to RSpec type tests. And RSpec, I shall show you some syntax in a minute. So they're Ruby-based tests, which perform some level of validation about the state of the system after you've applied your Terraform. Okay, you can use inspec, there's server spec, and there's like a basic server validation, which is GOS. Okay, but I'm going to talk a little bit about inspec because it's the only one that I've used myself. Okay, so after you've run your tests, you kill off your environment. You could just destroy the changes you made, but I would recommend kill off the whole environment after your test. You go and process the results. If bad stuff has happened, break the build, don't carry on any further. If the tests are good, then you can carry on down your pipeline and go and apply those changes to the target environment. Okay, it seems straightforward. Okay, so let's talk a little bit about inspec tests. The way that I've run inspec tests is by using Kitchen Terraform. Kitchen is a tool which we most commonly associate with Chef, but it can run all sorts of different types of tests if you want it to. Basically, you put together a series of controls. So here I've got 3 controls laid out. Here's an example of one. It's a very basic example. It's an inspec test which uses a certain type of syntax to describe what's expected of the system. And then you have a series of assertions. So in this case, it's simply asserting that the operating system is the one that's expected. Now, that doesn't sound like a very valuable check, but trust me, it is. I sat on 2 different client calls within an hour of each other yesterday. I've written these slides already. But on one client call, there was somebody who felt that a proposition about testing infrastructure was unnecessary because when I create a new image of a server, what I do is I type in the details of what I want the server to look like, I press go, and it spins up the one I want. You don't need to test that because it's repeatable, predictable, it's always going to give you the results you expect. Okay? Then half an hour later, I was in another call with a group of developers who were really frustrated because the servers that they were being given didn't even have the right operating system on them. If you had an automated test to check after you span up your new server, to check that it had the right operating system, that frustration wouldn't have been there. Okay? So while it is a very basic example, it is very real. Okay, so inspec. It works by applying these controls. And if you're using Kitchen Terraform, you can use the inspec evaluations, or you can use some of the rspec syntax, which is a bit more like evaluating, I can't think what the word is now. You've got these is expected to, and you've got matches. So there are different syntaxes. They both work using Kitchen Terraform because they're both rspec syntax. Just that on some of these examples, they'll look a bit different to each other, okay? Right. Okay, so when you run your Kitchen Terraform tests, you can execute them through your Kitchen CI beautiful WYSI console thing, or you can run them on the command line, which is probably a bit more as expected if you're running them as part of a CI pipeline. Here you can see that example running. It's only performing one check, but I mean, you can do hundreds and thousands of checks if you want to against your infrastructure. The other thing which comes out of a set of inspec tests is a test report, which is in the same sort of format as you would get out of a JUnit report. That means that you can display it in beautiful charts inside Jenkins with all the pretty green, I don't know what that thing's called. Anyway, and then you can drill down and see the test failures, and you can provide it as management reporting and measure metrics and failure rates. Okay? Something that inspec doesn't give us, though, is code coverage metrics. Now, this doesn't concern me because I have a pet hate of code coverage metrics, but I'm sure there are lots of people out there who do worry about code coverage, and certainly as you grow your infrastructure as code estate, expect more people to worry about the test coverage of your infrastructure code. Okay, so basically, with inspec tests, the limits are self-defined. Here's two more examples. The top one is just checking to make sure that you haven't got any passwords sitting in silly places. Perhaps if you've got one team who are building Packer images and another team who are deploying them to a test environment, you might want to go and verify the hardened state of the image that you've been given. Okay. The next one is quite a common one, actually, and I've sat through a test where somebody expected me to go and do this manually on every single server I span up, but to automate it would be absolutely awesome. So it's just a check to go and make sure the expected service is running when it starts. Yeah? An entry point, am I ready to continue down the rest of my pipeline? Okay, I know that was a really quick, whirlwind tour of testing Terraform. You can test your Terraform by writing Java-type JUnit tests if you want to. You can hook into the APIs of the various different platforms that you're using to go and verify state. But just have a play. I encourage you to go and invest that time in verifying the infrastructure is as you expect it to be. Okay? So, obviously, unit testing isn't the only way that we instill quality into our code. Static code analysis is another one, which now is fairly standard on application teams. Even if all that is you've got a set of plugins into your IDE and you check for common mistakes. Okay, I haven't used a SonarQube plugin for infrastructure code. I don't know whether such a thing exists, but certainly there are plugins which are available for most of the infrastructure languages that we can use just to do the checks for, am I doing anything bonkers? Okay. So, CFN lint and CFN nag are the ones that I've played with for CloudFormation. CFN nag I hadn't used until the other day when actually somebody I was teaching taught me about it. So, CFN lint is a fairly straightforward one. There's a plugin for IntelliJ, a plugin for Visual Studio Code. So you have a CloudFormation template, whether it's YAML, whether it's JSON, it can check for the sillies. Yeah, it can check before you go anywhere near your source code repository, whether you're doing stupid stuff. CFN nag for CloudFormation is a little bit like the next step up. It can perform checks for you on things such as, have I got open security groups? Am I about to open a port which I'm not supposed to open? And it can do all that before you go anywhere near your infrastructure platform. And that's really valuable because one of the ways that I've seen people checking and applying rules onto the state of their infrastructure is sort of after the case. If you use something like AWS config, you can define your own rules and check to see the state of your system after you've made the deployment. But with CFN NAG, it's highly customizable, so you could go and write your own rules and your own checks before you've made any changes to your infrastructure. Okay? So there are linting tools available for most of the others. I did like a pop quiz around my team. They all use TF-lint, but they only ever use it locally. And I think even if you're just doing that, you're just running a basic linting tool on your code before you check it into a source repository, it's offering value. So TF-lint on Terraform code, just to check for the sillies. There is an option on it, I believe. You can set it on the command line. You ask it to go deep into your resources, and it can check things which a Terraform plan wouldn't find. So the example which Andrew, one of my team, said was that if you use the deep, then it can check to make sure that you're not creating a load balancer which is already existing, the name's already existing in your infrastructure. There's no way a Terraform plan would tell you that. Or maybe you've got reference to an IAM profile somewhere in your code which doesn't exist. So finding that information out quickly, getting that fast feedback loop, helps improve quality further down the line. Okay. So that's linting, and I've talked a bit now about automated tools. But there is a lot to be said for the human tools that we have available to us for quality assurance. Now, while I said unit testing is just habit for application developers, I think code review is as well. Not everybody understands why they're code reviewing or what they're looking for, but code reviews happen. I would say almost exclusively with the infrastructure engineers I've worked with since starting Ubigo, code reviews don't happen. I do not know why. So we're working on that now. Code reviews, at least by pull request. Ideally, code reviews in a face-to-face peer review environment. That's what I would recommend. The code review's there for a second set of eyes. Again, you're checking for the sillies, but then you're also checking for consistency. So on the very basic level, naming conventions. If you're peer reviewing for naming conventions of resources, it aids your maintenance commitment. So if I've got a development team who are building out EC2 images, having a naming convention for your AMIs that people will know and understand and be able to recognize in the heat of the moment. Okay? Having a tagging strategy that you can review as part of your coding standards as you're creating your infrastructure. So consistency is important for maintainability. It's important for the bus situation which somebody talked about. If the rest of your team get run over by a bus, at least if you've got a set of coding standards, you can read and understand what it is they've created. But then peer review is also a great knowledge sharing opportunity. Yeah? Just reading other people's code is one of the best ways to learn. And I learn a lot about humans when I read their code. And if you want to take it to the next level, pair programming of infrastructure code in a one-on-one basis is a bit like the most intense code review you're ever going to have. Pair programming, I think I talk about this when I talk about blameless failure. If you're doing things together, you're learning together, you're making mistakes together, you're sharing together, okay? Right. The last one, acceptance criteria. Who uses acceptance criteria for the tasks that they work on a day-to-day basis? 2 whole people. Okay, so I am an agile evangelist. I teach people how to write good user stories. Okay, user stories aren't necessarily applicable when you're building infrastructure, but we have tasks. We define tasks of stuff we need to do. So I use acceptance criteria as the foundation for testing. In order to have a good test, you need to have a good set of acceptance criteria to understand what it means to succeed and to have finished doing a task. So when we're writing acceptance criteria with my development teams, we use the INVEST principle to help us build out and shape the user story. So the INVEST principle is there really to help you make sure that the task or the user story is ready and that you've evaluated all of these criteria. The most important one to me is that every task should be testable. To be testable, you need to understand what it means to succeed or to fail when you finish doing the work. So one of the ways that we write acceptance criteria on functional user stories is to use the given, when, then syntax. Now, I encourage teams to use given, when, then, even if they've no intention of writing automated tests, just to use these as a form of describing the expected manual tests, or even just the checks that you as a developer do before you say you finished the work. So given, when, then is equally applicable to infrastructure work as it is to application changes. And just writing it down helps you solidify in your head what the expected behavior of the system is. And you can choose to go turn these into beautiful BDD tests using some sort of Cucumber type framework, or you can just check it manually if that's what you want to do. Okay? So I encourage you just to have a think, go and write a given, when, then acceptance criteria, a few of them next time you do an infrastructure task, and see if it helps you understand your success on that piece of work. Okay, so I think I'm just about done on my quality rant. Okay, this is really important to me, and I think right now it's what differentiates the application developers I work with from the infrastructure developers that I work with. I can spot the people who have come into DevOps from a development background because these things are habit and they're doing them with their eyes closed. And the people that have come in from an ops or from an infrastructure world into infrastructure as code tend to, I'm trying to think what the correct term is, resist. Yeah, it's uncomfortable. But what I find really fascinating is that the people that have come from neither a dev nor an ops background, the graduates, so our graduates and interns who this is the only thing they've known and it's just normal and they embrace it and run with it. Okay? And that to me demonstrates that it's not a hard thing to do, it's just a habit that we have to unlearn. Okay? So, on to the next theme, which is excellence. Okay? In the Agile principles, there is a principle which talks about continuous attention to technical excellence. And lots of people forget about it because people dwell on the Agile Manifesto, which states that we value working software over comprehensive documentation. Okay? And they forget that if you value one thing over another, it doesn't mean that you don't value the other one. So design documentation is important, and that's why it's picked out technical excellence, and that continuous attention to your design detail is important. Okay? So I'm going to talk a little bit about some of the techniques that I use with my dev teams and how I'm starting to try and see my way through and how we can apply those to the infrastructure engineers as well. So one of the first things is when I've worked with teams going through a breaking down the monolith situation, we spend a lot of time, we invest a lot of time identifying the logical and physical separation of entities in our system to help identify the domain context boundaries between data as it flows through the system and to help us extract those individual microservices. Okay, I would say that probably my last project, which took 18 months, probably the first 3 to 4, we iterated over the service design to find the right shape of the code service that we wanted to build. Now, if you're building the infrastructure for a large microservices system, it is quite tempting just to go and model your infrastructure alongside the services that they're supporting. If you've got teams who are fully cross-functional, who build their infrastructure to match their services, that's amazing. But it doesn't necessarily follow that your infrastructure code should map to the shape of your application code. So you have to invest some time thinking about the logical separation of your infrastructure code. And the example that I'll give you is for the first application we built at Nubigo. It's a really small customer-facing application. It is very small, but we wanted to go and build it using the best practices. We used CloudFormation for this one, which was our first. And right from the beginning, we knew that we didn't need it all in one big template. Even though it's a small application and doesn't have a lot of AWS resources, we wanted to separate it out. And there are good reasons to do that. The first one is that we knew our networking needs. So we need multiple accounts because we needed development, test, and production. We understood the basic VPC configuration. And we also knew that for every environment that we were going to build, we'd need the same set of configuration. Okay? We also know that for every application that we build, we're going to roll out more or less the same networking configuration. So we put it into a CloudFormation stack of its own, and I don't touch it. I think that's the agreement. Emma doesn't touch the networking one. The next one is a CloudFormation stack, especially for security and permissions. For us, most of our applications, we use SAML for authentication, which means that, once again, we know for every application it's going to be a similar set of configuration. So having it self-contained that we can roll out to every application is a great way of logically grouping a set of IAM permissions, rather than putting them alongside the application that we're building. So our next CloudFormation stack is around storage. And the reason for that is that we know that in each of our environments, our storage needs are probably different. So we have considerably different database setup in our development environment than we do in our production environment. So keeping it separate allows us to parameterize it, really. Once again, it's not really an area that I touch, though I probably wouldn't break as many things in that area. But the top one is the application layer. So this is a CloudFormation stack which contains actually our front end and our back end code deployed onto EC2 servers, configured, in place, and then all the logging and monitoring set up. So we group that together because that's the one that changes most frequently. Yeah? I very, very rarely need to change my networking configuration. I sometimes, but not very often, change the permissions, maybe if I add a new service which is accessing a different AWS service. Database changes occasionally, and the application code changes regularly. So every time I update my application, we result in the stack being updated so that we can arrange for the CFN signals to be sent correctly. Okay? So the point here is that if you use nested stacks in CloudFormation, it gives you that freedom to separate out logical areas of your code. And the thought processes we went through were not about aligning things to front end or back end. They were aligning things to how much do I need to reuse it, how regularly is it going to change, and who's going to change it. Which are the things Emma can do and which are the things Emma must not ever do. Okay, so just a little bit of thought process into how you're going to lay out your code. When you start building infrastructure as code, it can be actually quite alarming how quickly your code base grows. Especially if you start separating things out into individual templates and individual stacks, and then extracting things into modules. When that happens in application code, we talk about dependency injection. I don't think we're quite at that level in the infrastructure as code world, but certainly there are tools that we have to help us manage the dependencies between resources and to inject parameters into our infrastructure code. So CloudFormation, again, mainly because it's what I'm most comfortable with. Here's an example of a CloudFormation template which is using parameters as I would expect it to. So there's a parameter which comes in, which you specify, which is the environment type, and then the whole template does different things. It's basically got different paths through the code, depending on whether I'm deploying into a production environment or a development environment. And we use CloudFormation conditions to do that. So in this case, all it's really doing is if it's production, it creates a massive instance. And if it's development, you can select from smaller ones. Okay. It's a lot more powerful than that, but mainly the code examples I've picked up are trying to give you the gist of what you can do. In terms of managing dependencies, so CloudFormation, as most infrastructure and configuration management tools do, provides you the ability to import and export variables from one place to another. So here's an example of database layer, which is exporting a variable which can then be used by the application layer. In this case, it's exporting the reference for a DynamoDB table that you can then reference later on in a totally different CloudFormation stack. Okay? That is useful if you want to go and apply application-specific permissions. So maybe I've got multiple services speaking to the same database, and each service should have different permissions. Okay. This one is a very basic dependency. So this one's a dependency within one stack. So in the example before, we had a database and an application in two different files. This one is inside the same file. And obviously, my EC2 instance can't do its thing unless it's got a database available. Okay, so there's a basic depends on syntax. In pretty much every tool that you will touch as an infrastructure developer, there is a way of explicitly declaring dependencies like that. So CloudFormation, when it's in one template, that's important because you can't guarantee the order that things are going to be in unless you enforce either a wait condition or a dependency. But the point is, think about it beforehand. It's that technical excellence piece about ensuring that you understand the dependencies within your code, and that you've invested time thinking about what that means for you as you deploy the code. So maybe, actually, this dependency isn't necessary. Maybe this is just adding time into my deployment process. Maybe there are things I could do in my application to break that dependency. Okay? And the last one on this note, and I've noticed this, I've put the peoply ones at the bottom of all of my slides as if they're the least important, but actually they're the most important. The value of a design review. So the financial services client that I worked with recently, they have a whole room full of people that review design documents for infrastructure, for security, and for applications. Okay? Governance over your technical design is important, but the most valuable type of design review is when you're in a room with a whiteboard and some pens and some sticky notes, and people who are empowered and encouraged to critique your design, to help you improve it, and to help meet the expectations of the system. Okay? So we, in the Agile world, we value people over process and tools. Okay. So it brings me on to my last theme, which is really the foundation of every successful team. Having a strong sense of purpose. Okay? Every single development team that I've worked with in the last 5 years, as a consultant or as a permanent employee, have been most successful at the points when they had a clearly defined goal. Okay? When it comes to infrastructure, having a clearly defined goal feels like an unusual thing to be thinking about. I would say that even on a backlog of incredibly technical content, as an infrastructure backlog is, it is valuable to have a product owner on your team. So the role of the product owner on a functional development team is to help you translate a business requirement into a technical requirement, and to help you understand why am I coming to work every day? Why am I building what I've been asked to build? And what is the value to my end user? And it's a little harder to grasp when what you're building is servers or tweaking an EKS cluster, but the value's still there. It is important to your company, it's important to you. And a product owner is a tough gig on a technical backlog. It really is a tough gig. And there are not very many product owners out there who will excel at this role. I'm not even sure I've met one. But if you can find that unicorn person who can translate a business requirement into an infrastructure need and can help bring you along for the ride with the why am I doing this, then they will add an awful lot of value to your team because they will help you understand your purpose in life. Okay. One of the ways that you can go find a product owner, if you can't recruit for one of these unicorn people that might not even exist, you can go make use of the product owners who exist on functional development teams. Okay? It's a bit of a mind shift, but an effective way of doing that is to go and embed your specialist infrastructure engineers onto application teams. It's one of the team topologies, so Matthew Skelton and Manuel, they talk about different team topologies. And one of the places where I've seen this work is to have your DevOps engineers and your specialist infrastructure engineers embedded on the development teams. That way your product owner learns about the infrastructure needs, but also your DevOps specialists learn and understand the why. Okay. And talking of cross-functional teams, people. So I have spent most of my last 10 years recruiting for full stack developers. I think it was probably some point about last January that I came to the conclusion that full stack developers don't exist, and that I was looking for something which I was never going to find. So T-shaped people is generally what people think of when they describe a full stack developer. Somebody that is a general specialist. So they have their core area, maybe it's front-end development, but they could apply themselves to everything that the team is working on. But I think as we move our expectations of everybody in our technical teams so that what we're expecting is more of a DevOps engineer type role, we need comb-shaped people. Now, comb-shaped people have vast expectations on them. They need to be able to do their thing to expert level, but their thing is lots and lots of things. I need to be able to write code. I need to be able to script. I need to be able to orchestrate containers. I need to be able to write CloudFormation templates. I need to be able to understand the security of my system. I need to be able to put up guardrails. I need to be able to write tests. Suddenly the expectations grow and grow and grow. And are we a specialist in anything? We have to be specialists in everything. Okay? Finding comb-shaped people and having one or two of those on our team is a tough ask, but it will help the team work towards meeting their goals. Okay, my very last piece. If you've ever seen me talk about blameless failure, you know that I live and breathe the team. It has been a massive, massive mind shift for me to move from development manager into leader of people in a business, because I'm no longer sat there in a team. As you can tell, I don't write code anymore. It gives me the heebie-jeebies sometimes. Doesn't mean that we can't live the team. So when we're talking about infrastructure as code, less working independently, more working together, we collaborate, we share, we pair program, we have sprint reviews or some form of demonstration of our work to others, we have sprint retrospectives or some form of self-reflection and inspection. Okay? And building in those small, agile changes, whether or not you're going to go full-on Scrum or not, building agile ceremonies into your weekly team-based activities genuinely does help. It helps improve this feeling of shared ownership. It helps improve our psychological safety because we learn about each other's flaws and each other's strengths. And we can go build awesome stuff together. Okay? So we've talked a little bit about the things I've learned. I will be here for a short while afterwards. I think the adrenaline's helped me feel a lot better. We can talk about the things that you've learned. So simplicity, quality, technical excellence, and a shared sense of purpose. Hopefully we can apply these things to infrastructure as code and help us move as fast as the developers who are biting against our heels.